So what I'd like to do is give you some global context on energy use. Why do we use so much energy, in particular fossil fuels? A quick look at the Canadian energy situation and what it would take to do an energy transition. Some people think that there's an easy switch out from fossil fuels to renewables or zero carbon energy, and that's maybe a little more difficult than some would like. The pipeline issue and the Paris Agreement, which Gordon already talked about, the declining revenue return on non-renewable energy assets that Canadians are receiving, and finally implications on, given the climate commitments that we made in Paris, and future energy security. So if we look at the world, this is the last 50 years of consumption by fuel. We can see that, first of all, world energy consumption has more than tripled, and 86% of that is fossil fuels. This doesn't include traditional wood burning. If we look at 2014, this is the breakdown in consumption by fuel. As I said, 86% fossil fuels. Hydro and nuclear are really the next major sources, and non-hydro renewables are only 3%. And they've grown exponentially, wind, solar, geothermal, and biofuels, but they've grown from a very small base, so they're relatively insignificant at present. Why has consumption of energy grown so much? Well, for one thing, the population of the planet has virtually exploded in the last century and a half. It's quadrupled in the last 100 years. We're now at 7.4 billion people, a forecast to go to 11 by the United Nations by 2100. The second thing is per capita energy consumption. We really got started on fossil fuels in about the middle of the 19th century, say 1850. We burned some coal before that. But in 1850, it was 80% biomass and 20% coal. People think that oil substituted for coal, but in fact it didn't. Oil really just added to the per capita consumption of people. Natural gas added further, and nuclear energy added still more. So oil and gas really got started after the Second World War. And when you add it all up, 87% non-renewable. This includes traditional biomass. So per capita consumption in the world has increased ninefold, and population has quadrupled in the last 100 years. If we look at per capita consumption by country, we can see, first of all, that Canadians consume about 5.3 times as much energy per capita as the world average. We consume 18 times as much as the average person in India. Per capita consumption has been declining in the industrialized world, Canada, the US, but it's been growing very fast in the non-industrialized world, China and India. China has averaged a 7% growth in per capita consumption per year for the last 15 years. India is up by 4%. The world as a whole is up by about 1%. If we look at individual countries in 2014, we can see where Canada stacks up. So Canada is second from the left-hand side here. 5.3 times the world average, considerably more than Americans. If we look at the OECD countries of the world, the industrialized countries, and that accounts for 18% of the world's population. They consume 3.4 times as much energy as the non-industrialized world, 82% of the world's energy. And the problem is, the non-industrialized world aspires to first world levels of energy consumption. If we look at the consumption of oil, gas, and coal, since 1850, since we really got started, it's pretty interesting to me that 90% of all the fossil fuels ever burned have been burned since 1941, and 50% since 1989. So we're really accelerating in terms of our consumption of fossil fuels and energy in general. Canada started from a relatively high level, but our consumption has nearly tripled in the last 50 years. 2/3 of that is fossil fuels. If we look at Canadian consumption in 2014 by fuel, we can see that hydro is very important in Canada, large hydro, but non-hydro renewables were less than 2%. They've grown very radically in the last 15 years, but from a very small base. When people think about renewables, they think about things like solar and wind, which are really electricity. That's what they produce. But electricity is only 17% of our delivered energy. So we use a lot of oil and gas for transportation, for heating. And so even if we could completely replace electricity by renewable energy, that's only 17% of what we're using. Transport is a quarter. Industrial uses are a little over half. If we just look at electricity generation, we can see that non-thermal sources, zero carbon sources, are about 78% of Canada's consumption. And if we look at thermal sources, we can see that most of those are coal and gas. A little bit of wood and biomass. But if you add up all of the renewable non-hydro sources in this picture, only about 3.3% were non-hydro renewables in 2015. So it's a big task to switch that out. If you look at wind, this is wind capacity installed in Canada from 2006 to 2015. First of all, huge growth. Ontario, Quebec, and Alberta is third in terms of wind capacity. It's grown by a factor of 5, but from a very small base. If we look at the Achilles heel of renewables like wind and solar, they happen to be intermittent, so they have to be backed up for times when the wind is not blowing and the sun is not shining. So the red here is hourly output variation, and the yellow is weekly average. So if you install a kilowatt of wind capacity, your average generation from that is only about 21% at a place like Calgary. If you look at solar, it's the same thing. And typically the biggest solar output is in the summertime, when some would argue we need it less. But the average capacity factor of solar is about 16% at the latitude of Calgary. I'm going to be using some of the NEB forecasts from their latest update published in October last year. And this is their reference case outlook for generation by source for Canada. And in essence, carbon-free sources, nuclear, renewables, and hydro are about 80%. Fossil fuels are the other 20%. You can see the coal phase-out at the bottom. But the coal phase-out is essentially replaced with natural gas in this picture. Wind and solar are forecast to grow by 100%, so quite an aggressive forecast. But you can see how much they contribute to the total picture. If we look at non-hydro renewable generation in the world, this is how it stacks up. Denmark, 57% of its electricity comes from non-hydro renewables, mostly wind. Germany, we've heard a lot about Germany, 23%. World as a whole, 6%. Canada, 3.5%. If we add in large hydro as a major renewable source, Canada looks pretty good. 65% of Canada's electricity generation was non-hydro renewables in 2014. We've talked about global warming. This is the latest data to 2016. And the world has grown in temperature by about a centigrade since 1980. So this is a big concern. That's what the the Paris Agreement is all about. Per capita CO2 emissions have fallen, in essence, in the developing world, but Canada is still about 4 times the world average. Emissions intensity, CO2 emissions per dollar of GDP. Really, this has improved. Economists like to talk about this. But if you look at the emissions per unit of energy consumption, it's much flatter. Canada looks pretty good at the bottom there in the red because of all of our large hydro sources of electricity. China is very poor because of all of the coal it burns. It gets over half of its electricity from coal. Denmark, in the blue, has made huge improvements since 1990, but it's still much, Canada's still much better in terms of CO2 per unit of electricity generated. If we look at oil and gas, we can see that Canada, or particularly Western Canada, which is where most of it is, we have a little bit offshore Newfoundland, but most of it comes from the 3 or 4 western provinces. There's been a little over 800,000 oil and gas wells drilled in Western Canada. About 220,000 of those are still producing. So the colors here are different classes. If we look at oil production in Canada from when it got started back in the 40s to 2040, this is the latest projection from the NEB's October update. And they have a reference case, a high price, and a low price case. But in essence, conventional oil peaked back in 1973. It's been fairly flat since, and the prognosis for the future is fairly flat. And that could even be an optimistic prognosis. So the only hope for growing Canadian oil production is the oil sands, is bitumen. And according to the reference case forecast of the NEB, 75% of Canadian oil production will be bitumen by 2040. So that's how important it is, if you believe it's important, to grow Canada's oil production. That's where it's coming from. Gordon alluded to this a little bit, but this is the Athabasca McMurray oil sands pay thickness. The Athabasca deposit is about 83% of total bitumen. There's some in Peace River and some in Coal Lake, but this is the most important. And at the top, this is color-coded by pay thickness, by the quality of the resource. And you can see at the top, there's some purple deposits. Those are 60 to 70 meters of pay thickness, shallow. So that's the mineable part of part of the tar sands. The in situ is a much bigger area, again variable, but a lot of it is very low quality. And the low quality parts of the deposit will necessitate higher emissions and higher prices in order to make it economic. So as Gordon mentioned, companies go after the highest quality, most economic parts of the deposit first. This is a breakdown of bitumen reserves in Canada. The crosshatch part has been recovered. We've recovered about 6.5% of what's there. The parts that are pushed out a bit on the right-hand side are bitumen reserves under development. So these are being actively exploited. And the actively exploited part of the bitumen is 89% mineable. Only 11% of what's being developed is in situ at present. But if you look at what's not under development, 92% of that is in situ. So it's the lower quality, higher emissions part of the tar sands that are going to be left. Alberta imposed the 100 megaton emissions cap on the tar sands, and this is what it looks like. Emissions from mining, upgrading, and in situ. The CAPP will be reached in the NEB's high price case in 2023, in the reference case in 2025. But as Gordon mentioned, that allows emissions to grow by 47% over 2014 levels. If we look at what that does to Canadian production, this is what Canada would have to use for itself and to export. We really hit a peak of production in the middle of the next decade. If you look at existing export capacity and rail loading capacity and domestic consumption, there's enough existing export capacity to handle all of the bitumen under the emissions cap. However, the pipelines are essentially full, and the incremental part of it would have to be transported by rail, which is can be roughly double the cost of moving it by pipeline. So that's why companies are very keen on building new pipelines. Trudeau approved the Line 3 expansion and the Trans Mountain expansion. Trump was elected. Basically, he's green-lighted Keystone XL. Keystone XL, if you compare it to Trans Mountain, would be somewhat more benign environmentally, just because of the terrain it crosses and the fact that you don't need tankers with Keystone XL. And it's moving bitumen to one of the highest concentrations of refineries that are able to optimally handle bitumen, which is located on the Gulf Coast of the US. So if Line 3 and Keystone get built, which is likely to happen, there would be a 13% pipeline only of excess capacity to handle all of Canada's bitumen under the emissions cap. So Trans Mountain is totally extraneous in this situation, and so is Energy East. It's just not needed. And the CEO of Enbridge came out not long ago basically saying that if two of these pipelines go ahead, we certainly don't need any more after that, if Notley's emissions cap holds. And if Notley's emissions cap holds, this is what emissions look like. So the black line is the Paris Agreement, 30% below 2005 levels by 2030. And the bottom segment here is oil and gas. In essence, about 25% of emissions right now in Canada. If the CAPP goes ahead and we grow oil sands production to 100 megatons, oil and gas would be 45% of Canada's emissions by 2030, if the Paris Agreement is met. So that means all other sectors of the Canadian economy have to contract by 47%, which I would argue is difficult and likely impossible. If we look at natural gas, again, this is the NEB projection and the history back to 1950. Canada's natural gas production peaked in 2001. We're now down about 15% below peak. In terms of history, Alberta was the most important source of natural gas in Canada, followed by British Columbia. In terms of the forecast, BC is going to have most of the growth in gas production, and that will be largely from tight gas and from shale gas, both of which are developed by horizontal fracturing or fracking. If we look at what's available for natural gas in Canada, we have what's called proven reserves and unproven resources. Proven reserves are about 70 trillion cubic feet, roughly equally distributed in BC and Alberta, a little bit in Saskatchewan. So of what we know that we have for sure, like reserves are proven by the drill bit, we only have 70 TCF. If we add in what we think might be available, we have 1,230. That 1,230 came from 3 studies done by the National Energy Board since 2012, mainly, looking at tight gas in the Montney, shale gas in the Horn River of BC and the Liard Basin of BC and the Yukon. And those are, I would say, are highly optimistic studies, having reviewed them. They allowed tight gas resources to be almost quintupled and shale gas resources to be more than quadrupled. Conventional gas, however, is down 40% from 2007 levels. Frontier and coal bed methane didn't change, really. If we look at the NEB's forecast for production, 2016 to 2040, where is it going to come from? Well, they're assuming that 153 trillion cubic feet of gas will be recovered over that period of time. So that's more than double our proven reserves. And 3/4 of that will come from tight gas and shale gas, developed by horizontal fracturing. Only 1/4 of it will come from conventional, which has produced the bulk of Canada's gas in the past. I'd like to just quickly look at royalties. This is information from the Canadian Association of Petroleum Producers. So this is what we get for selling our non-renewable resources. Over the 2000 to 2015 period, royalty revenues are down by 63%. Oil production is up over that same period by 75%. And oil and gas production combined is up by 27%. So production is going up, and our take in terms of revenue from royalties is going down. If we look at Canada, looking at the percentage of all sales of oil and gas that are returned to the government in terms of royalty revenue, 2000 to 2015 again, we can see that back in 2000, roughly 17% of net sales were returned to governments in the form of royalties. By 2015, that had dropped to 4.5%. And again, over that period, oil production is up 75%. Oil and gas production up 27% combined. Royalty shares of revenue as a percentage down 74%. If we look at BC, natural gas royalty revenue, it peaked in 2005. And since 2005, even though natural gas production has doubled, royalty revenue is down by 84%. So oil and gas revenues in BC are only about 1% of total government revenues. If we look at Alberta, Alberta has some pretty good data on how much it has actually got from the oil and gas industry in terms of lease rentals and royalties. And this is the percentage of government revenue from 1970 to 2015. And back when Peter Lougheed set up the Heritage Trust Fund, nearly 80% of Alberta government revenue came from oil and gas. 2016, according to the latest budget estimate, that has dropped to 3.3% of total revenue. So basically a collapse in terms of what the oil and gas industry actually provides to Alberta. Since 1980, oil and gas production has doubled in Alberta. Revenue as a percentage, actually revenue in real terms is down 90%. So one has to question what we're getting for all of this development. So just to summarize, oil and gas are likely to remain an important component of Canadian energy consumption for decades, given their energy density and utility, for which there are few scalable substitutes. I am as much for renewables as anyone, but I also think we should be aware of the difficulties in making that transition. Hope for expanding Canadian oil production lies with bitumen, which is a high-cost and high-carbon source of oil. Companies extract the highest quality resources first, and better technology is unlikely to offset the emissions impact of moving to lower quality deposits, as higher quality deposits are exhausted. There's a lot of talk in the industry about reducing emissions intensity, and it's true that emissions intensity has been reduced in upgrading, but not substantially in mining or in situ in the last half dozen years or so. NEB's estimates of remaining gas resources are highly optimistic in my view. Accelerating production for a nascent LNG industry is ill-advised, given that it will further compromise Canada's climate commitments and energy security if those gas resources are not there. These resources will be needed domestically in future at some level, and production is largely dependent on hydraulic fracturing, which has been shown to have high greenhouse gas emissions and other environmental impacts. The cap on oil sands emissions at 100 megatons per year will allow production to grow by 53% and emissions to grow by 47% over 2014 levels. This will make Canada's commitment under the Paris Agreement virtually impossible to meet. Despite record levels of production, Canadians are receiving radically reduced returns from the oil and gas resources they own in terms of royalties and rent. Canada has no energy strategy beyond liquidating its finite non-renewable resources as quickly as possible. 20 LNG export terminals and 3 new export pipelines have been approved without a long-term plan. These are strategic resources that will likely be needed at some level by Canadians in the future. Their production comes with significant environmental impacts and deserves a long-term strategy for the sake of future generations and the environment.
Hi, thanks for the presentation. I'm questioning your predictive impact of in terms of market share for solar, and wondering if we're underestimating the potential disruptive influence of that in the electrical generation sector. And the example I'd like to use is the recent bid by Nevada Power Corp to provide electricity at under 4 cents a kilowatt hour. And that's rather huge in terms of electrical generation on a large scale in that energy sector. And I'm wondering what the implications are going forward, especially given the rapidly advancing technological aspect of solar that's going on behind the scenes as well.
I sure hope they're right. You know, thermodynamics kind of rules at the end of the day, and the intermittency issue with solar is real. Storage is a big deal. You know, batteries can be brought down a lot in terms of cost. You know, right now, solar that makes sense is really grid-connected solar, so you can use the grid as backup. But the fossil fuel sector is being basically they're the backup, and it's really hurting their margins. If you look at what's happened in Germany, it's driving some of the fossil fuel generators out of business because solar and wind in a place like Germany are always used first, and then you back it up. So some of the economic assumptions that were made when those power plants were built are not there. You know, with the large inroads of solar. And, you know, in terms of Canada, Canada is quite a ways north. And wind is probably, you know, a pretty good option. I say, you know, both of them. One of the things Gordon said was conservation, not efficiency. I think that has to be a really big part of any plan going forward. And distributed solar, like rooftop solar. You know, I use solar to pump all my water. I live in a rural setting on an island on the west coast. Perfect. You know, I used to have to wheel a Honda generator down to pump up water. So in certain applications, it's fantastic. And there's a lot of enthusiasm, and I really hope it's right. But at the end of the day, I'm a kind of a realist and a numbers guy. And my favorite 3 words are beware of scale, you know, when you're trying to scale some of this stuff up.
Next, maybe last question for this section. Correct me if I'm wrong, but I believe that our government never hid the fact that to meet the emission standards would be impossible. They knew that in advance, and they clearly expected us to pay our taxpayers' dollars to offset the shortage, which will not be covered by the reduction, by buying the credits, so-called emission credits, somewhere in the Middle East, or I don't remember where exactly they plan to buy it. Is there any evidence that buying those so-called carbon credits help to reduce any emission standards, any emission levels anywhere? I assume we have the similar program in British Columbia. Do you believe it's an effective way of spending, or does it even help to reduce anything? Thank you.
Yeah, that's a good point. I'm no expert on that, but there's been a lot of cynicism about buying emissions credits and carbon trading. You know, I guess it has to be policed very carefully. And we'll see, because you know that's a big part of a lot of industrialized nations' plans in terms of meeting their commitments on climate.